Dear students, this is the MCQ from the concept errors. In the problem, it is clearly given that the density of a sphere is measured by measuring its mass and diameter. If it is known that the maximum percentage errors in the measurement are 2% and 3%, then find the maximum percentage error in the measurement of density. We know that the density of a sphere is mass by volume of the sphere. We know that the volume of the sphere is 4 by 3 pi r cube. From the error limits, the percentage error in density is equal to the percentage error in mass plus the percentage error in its radius. So clearly given that the percentage error in mass is 2% plus 3 into the percentage error in its radius is 3%. So finally you will get the 11%. So the fourth option is correct. Dear students, this is the MCQ from units and dimensions. The dimensions of physical quantity x in the equation force equal to x by density is given by force is equal to x by density. So the dimensions of density x is equal to force, the dimensions of the force into density. So we know that the dimensions of a force is ml t power minus 2 and the dimensions of density is mass by volume like m l power minus 3. So finally the dimensions of the x is m square l power minus 2 t power minus 2. So the option third one is right answer. Dear students, this is the MCQ from the units and measurements. The velocity v of a particle at a time t is given by v equal to at plus b by t plus c, where a comma b and c are constants. The dimensions of a comma b and c are respectively. See, v equal to at plus b by t plus c is given. According to the principle of homogeneity, the dimensions of v is equal to the dimensions of at as well as the dimensions of v is equal to the dimensions of b by t plus c as well as the dimensions of c is equal to the dimensions of t. So from this the dimensions of a is equal to the dimensions of v by t. It is clearly given that here v is velocity. The dimensions of velocity is l t power minus 1 and the dimensions of time is t. So finally we will get the dimensions of a is l t power minus 2. The dimensions of a is l t power minus 2 as well as the dimensions of c is equal to the dimensions of t. We know that the dimensions of t is nothing but time. So C equal to T. From this, the dimensions of B is equal to the dimensions of V and the dimensions of C is T. So, the dimensions of velocity is L t power minus 1 and the dimensions of time is T only. So, finally, the dimensions of B is equal to the dimensions of L. The dimensions of B is equal to L. So, finally, the dimension of A is L t power minus 2, the dimension of B is L and the dimensions of C is T. The fourth option is correct.